Sulfur also enters the atmosphere from several natural sources. Hydrogen sulfide, a colorless, highly poisonous gas with a rotten egg smell, is released from active volcanoes. Sulfur dioxide, a colorless and suffocating gas, also comes from volcanoes. These gases go into the atmosphere and cause acid rain.
Sulfur dioxide enters the atmosphere from factories. There it is deposited as acid rain, which gets absorbed by plants. In the oxygen-deficient environments of flooded soils, freshwater wetlands, and tidal flats, specialized bacteria convert sulfate ions to sulfide ions. The sulfide ions can then react with metal ions to form insoluble metallic sulfides, which are deposited as rocks or metal ores, and the cycle continues.
Most forms of life get supplies of critical nutrients from compounds containing carbon, nitrogen, phosphorus, and sulfur that are circulated into their respective chemical cycles. These cycles are driven by gravity and by the one-way flow of energy from the sun. Sulfur enters plants by acid rain, and when animals consume these plants, the sulfur enters their bodies as well. When the plants and animals decompose, the sulfur from their bodies enters the soil.
Organic matter is broken down by anaerobic decomposers in flooded swamps, bogs, and tidal flats. Sulfur dioxide, a colorless and suffocating gas, also comes from volcanoes. Ammonium sulfate enters the atmosphere from sea spray, dust storms, and forest fires. Plant roots absorb sulfate ions and incorporate the sulfur as an essential component of many proteins. Certain marine algae produce large amounts of volatile dimethyl sulfide, or DMS. Tiny droplets of DMS serve as nuclei for the condensation of water into droplets found in clouds. In this way, changes in DMS emissions can affect cloud cover and climate. In the atmosphere, DMS is converted to sulfur dioxide, which turns into sulfuric acid. And tiny droplets of sulfuric acid also react with other atmospheric chemicals, such as ammonia, to produce tiny particles of sulfate salts.
Sulfur enters the atmosphere through human interactions like mining and extraction of sulfur in soil, rock, and fossil fuels. It is released in the atmosphere through smelting, burning coal, and refining fossil fuels. It enters the atmosphere through pollution released by factories. Human activities are degrading the Earth's natural capital by increasingly altering the rates at which energy flows throughout these cycles, and the rates at which critical chemicals are recycled. This is a major intrusion into the process of energy flow and nutrient cycling that support life on Earth. Without human impact, sulfur would stay in rocks for millions of years until it was uplifted through tectonic events and then released through erosion and weathering processes. Instead, it is being drilled, pumped, and burned at a steadily increasing rate. Over the most polluted areas, there has been a 30-fold increase in sulfate deposition. Although the sulfur curve shows shifts between net sulfur oxidation and net sulfur reduction in the geologic past, the magnitude of the current human impact is probably unprecedented in the geologic record. Human activities greatly increase the flux of sulfur to the atmosphere, some of which is transported globally. Humans are mining coal and extracting petroleum from the Earth's crust at a rate which is more than double the rate of 100 years ago. The result of human impact on these processes is to increase the pool of oxidized sulfur in the global cycle, at the expense of the storage of reduced sulfur in the Earth's crust. Therefore, human activities do not cause a major change in the global pools of sulfur, but they do produce massive changes in the annual flux of sulfur through the atmosphere.